Innovative sealing solutions are an important part of our strategy for the future. We are currently faced with the challenge of increasing use of alternative fuels by automotive manufacturers in their drive technologies. Behind this development are the efforts being made worldwide to reduce greenhouse gas emissions as quickly and efficiently as possible through the use of alternative fuels. This will also help to reduce our dependence on fossil fuels. Global warming, a secure energy supply, and competitiveness are the key issues facing the European Union. This is why the primary goal of European energy and climate policy is to curb the pace of global warming. At present, the use of biofuels, combined with increased efficiency in vehicle technology, is seen as the only possible alternative to oil. Consequently, this represents a crucial component of European energy and climate policy. The European Commission has proposed a target of 20% reduction in greenhouse gas emissions to be reached by the year 2020. In addition, discussions are currently being held at EU level on the possibility of mandatory replacement of at least 10% of gasoline and diesel with alternative fuels also by 2020.
Anybody who uses liquid fuels, and this includes industry as well as motorists, are going to have to become accustomed to and be prepared for the use of biofuels in the future. They're already being used now, but they're going to be used to a greater degree as time goes on. This affects everybody in the world, not just Europe and America, but everybody who uses an internal combustion engine is going to be affected. The days of cheap and abundant oil are over. The price has gone from $96 to $144 this year alone. Biofuels are coming, that's for certain. The question is industry going to be prepared for the consequences, both intended and unintended?
Today, when we talk about biofuels, we are referring to first-generation biofuels. These are relatively easy to produce, based on native oils that are converted into biodiesel through a process of transesterification. The alternative is bioethanol, based on corn or sugarcane. It is produced for use as a gasoline additive. It is used as an additive rather than a pure fuel for two reasons. Firstly, because its energy density is relatively low, and secondly, because first-generation biodiesels cannot be produced in sufficient quantities to be used as the sole form of fuel. Besides this, the aging processes associated with biodiesel have a considerable impact on the vehicle seals. Oxidation produces acids that can chemically attack the seal materials. That is why it is important to choose the right material for a specific application. To make the selection easier, we have developed a traffic light system.
From the production to the gas station and then to the fuel and exhaust system, biofuels presents new challenges to technology. Specifically, when gasoline is concerned, alcohol penetrates the seal and causes the elastomer to swell. This increased swelling is related to the polarity and small size of the alcohol molecule. As the swelling increases, the mechanical properties of the seal decrease.
On the global scene, an important issue in terms of environmental protection and dependency on fossil fuel is the increased use of renewable fuels. For example, China is planning for its rapidly expanding transportation fleet a massive share of biofuels. In South America, large quantities of biofuels are made from sugarcane. For this reason, in Brazil, 75% of all newly registered vehicles are flex fuel models that burn E85, which is widely available there. In North America, ethanol is currently made from maize. Second-generation refineries, some already under construction, will make ethanol from cellulosic feedstocks such as wood.
When we talk about second-generation biofuels, we generally mean designer fuels or synthetic fuels, produced by a fully synthetic process. These are based on lignocellulose, which is the main component of the biomass. This means that there is potential for producing very large quantities per hectare of synthetic fuels. At the same time, there is a very high potential for reducing CO2. As a result, we have an energy self-sufficient production process and a premium quality fuel.
The second-generation biofuels, for example lignocellulosic ethanol, will have similar effects on the elastomer. Elastomers suitable for biofuels must be particularly stable with regards to the aging of the fuel to avoid failure in the field. For this reason, we are working closely with the fuel manufacturers, our suppliers, and the automotive industry. Depending on the blend ratio with the fossil fuels, elastomers will display varying levels of resistance. For example, when gasoline is added to ethanol, a blend ratio of 25% ethanol places the toughest demands on the elastomer.
In some respects, the physical and chemical properties of biofuels create new conditions and significantly more demanding applications in the field of engine technology. Here, it is our mission to find innovative solutions. Beside the chemical properties of the fuels, the conditions that seals are subjected to in fuel systems are becoming tougher and tougher. This is because fuel pressures are becoming higher in order to achieve more efficient combustion. From the inlet of the fuel tank to the injection valve, the fuel comes into contact with a wide range of pipes and systems, and the seals need to work faultlessly throughout. Additionally, blow-by effects can impair the physical properties of engine oil. Here at Trelleborg Sealing Solutions, we have a specific procedure in place for rating materials according to their suitability for use with biofuels. This procedure is called the traffic light matrix, and it describes the criteria we use when we test materials. There are 5 criteria in all: hardness, tensile strength, ultimate elongation, change in weight, and change in volume. So how does our traffic light system work? If a red light is displayed, that means the material does not meet the criteria for the application. And in the case of a green light, that means we are certain that the material, which of course was tested in advance, is suitable for the application. Besides its effect on elastomers, there are other potential impacts that need to be studied before the fuel is approved. With ethanol, these include the effects of vapor pressure and phase separation into the gasoline when water is absorbed. Biodiesel leads to increased thinning of the lubricating oil and consequently to corrosion and coking. Malfunctions and engine failure may occur as a result.
Apart from optimizing the compatibility to the new fuels, another goal for us is the improvement of the overall properties of our elastomers. In particular, low temperature flexibility is a key challenge in many automotive applications. Furthermore, seals operating in high pressure must be specifically formulated to be resistant to explosive decompression. With every development from Trelleborg Sealing Solutions, the elastomer and the part geometry are designed to keep swelling or shrinkage to a minimum. For example, the combination of the high pressures associated with gasoline direct injection and the alcohol contained in the fuel combine to create a very severe environment. For this application, a highly optimized product has been recently developed.
In the simplest case, using a different material can be an adequate solution. For example, gasoline tanks have static seals, and the pressures are very low. This means we can exchange a seal made from a standard elastomer for one that is made from elastomer that is more compatible with the conditions faced. This example illustrates the high-pressure pump in a fuel system. The injection pressure is created by the oscillating pump's pistons. We have engine oil on the drive side and fuel on the pump side, and the seal in between them prevents the two from mixing. This is a 3-part seal made from a PTFE-based seal with sealing lips in both directions and 2 elastomer O-rings that function as pre-stressing elements. When it comes to the design and choice of materials, our main focus was on achieving a good wiping effect, high resistance to wear, the ability to function at temperatures down to -40°C, and stability in the presence of biofuels. For other applications, for example involving dynamic sealing or extreme pressures, as well as using higher grade materials, we also need to modify the design of the seal.